Yo, what's up, everybody? Welcome back. Today we are working on my map, and the topic for today is integrating bus schedules to our path planner. So, context for the application. This is a map of Vancouver. I sometimes want to get around Vancouver, and I want to take the bus, and I want to go from like one part of town to the other part of town. And bus schedules are like sometimes hard to predict, and so I might go into Google Maps and I might say like, hey, how do I get to the bar that I want to go to, and will I be able to get back from the bar at night, or am I gonna have to like leave before 2 a.m.? Like, what's the situation here, right? And Google Maps will tell me what I think are just like brain dead bus routes, right? They'll say things like, walk instead of walking 3 blocks, you'll take a bus, and then they make assumptions that like the buses will come on time and you'll be able to make transfers. That's not always true, and so you might take their suggested route, and it won't get you there as fast as if you did something that was like theoretically slower, but more consistent. And so I know that there are like things that I like in my like route planning. I know that I value like consistency of bus routes over speed, right? So I would rather take 2 express buses, even if it takes me a little further out of my way, than take 3 non-express buses because I know that they're less consistent. I also think that I walk maybe a little faster than the average person, or at least the average person that Google knows about. I don't want to walk down main streets, right? So there's all of these like things that I know that I want, and so my goal here is to make like an infinitely tunable. Infinite is strong, extremely tunable path planner, right? And so what we have right now is we have a map of Vancouver. I can like select any of these like nodes on this graph. I can say things like, hey, I want to plan a route from here to here, right? And it'll do it. It's doing something pretty silly right now. It's just doing like a basic A star. But it's starting to like resemble something, right? I can do things like I can say like, hey, maybe like prioritize going straight, and so then we'll get like a nice little L shape instead of like that like zigzaggy thing. We can also do things like say, hey, let's look at like sidewalks, and let's kind of make them like orange or something, because why not? And then I can kind of say like, hey, I'd prefer to walk on sidewalks than everything else. And so then we can see that like the line starts to take sidewalk only paths instead of walking down the middle of the street. So what we have right now should give us something that we can use to say like, I'm on my bike and I want to take a bike route. That should be doable right now. Or like I'm walking, I can plan a route from A to B on foot. But transit integration is the big thing, and so that's what we've been working on for the past few days. Yesterday, we kind of ended up at the point where we had something that like started to resemble what we wanted, but it's not quite there. And like at the end of last stream, it wasn't really working, and so the first thing we're going to do today is try to debug the absolute broken state that we left it in. Just for like to recap, kind of like the plan for bus scheduling. Right now we're using A star. We're using this like distance-based metric for scoring, right? So every time you walk 1 block, you get like 1 block's distance worth of cost associated with that thing. And A star uses this like heuristic algorithm to guide where you're going to go, right? So if you're trying to get from like here to here, right, it's going to say that like nodes that are closer to like the final destination are like worth more to look at than things that are farther away. That completely breaks down when you add in the bus routes, because one, distance is no longer like your metric, right? Our bus schedules, we have like kind of like times that a bus is going to arrive at each stop, which is like kind of fundamentally different than distance. There, you can convert from distance to time if you have like a relatively like constant walk speed, which we're going to assume for now, but we do have to make sure that we're working in like time units instead of distance units. And then the other thing is, right now our heuristic for which nodes to look at first kind of depends on the fact that like closer nodes are faster to get to the end result, and that's not true anymore once you add in buses. So the current plan, we'll see if it works, is like if I'm like here and I want to get on the bus that's like here, right? But maybe I'm going like over here somewhere, right? So I'm going like from like here up and to the right, but it's faster to go to this bus that goes down here and then take a bus that goes up here or something, right? How can we like represent that? So the goal is kind of to just kind of like hook it straight at like the closest bus stop. And then once we get to that bus stop, we can kind of say like, oh, we have like reached this bus stop, and we can kind of choose to maybe go to the next bus stop. And so I want to change my heuristic to, instead of saying walk towards the destination, I want to have it be walk towards the closest bus stop that we haven't looked at yet, or the closest bus route that we haven't looked at yet. And so I think that, because we're kind of making the assumption here that buses will be faster than walking sometimes, right? And so we're gonna kind of like run it down towards a bus route. Once we hit that one, that route's no longer a target. We'll then hook it towards the next one. And eventually we won't have any bus routes that are closer to us than the final destination, and then we'll start walking towards the destination. Once we get on a bus as well, it should like cascade that effect pretty heavily, because once we hit a bus stop, then it should have pretty low cost to get to everywhere else on that bus route. That's kind of like approximately what I'm thinking. So that's kind of like what we've been working towards. We got to the point yesterday where we had some code that we think will send us towards the closest bus stop, but it was broken as shit. So the plan of action for today is to kind of like fix our benchmark app, because I want to like right now, like testing kind of like by doing like this is really hard, especially in the scenario where moving one step just like completely freezes the app. So I want to have like some sort of like programmatic way to test different scenarios. So we have to fix our benchmark app because we like made a bunch of API changes that like weren't compatible, and we just commented it out instead of fixing it. We have to debug the massive slowdown, and then once we do that, if it works, then we have to fix the like transit calculation. So if we can make it to a bus stop, then we have to like be able to board the bus and figure out like where the adjacent bus stops are at what time, etc. And then I want to visualize kind of like the path planner. So right now we have like this like visualization where we can see all of the nodes that we hit as part of our search. I kind of want to see something a little bit more like detailed than that, where I kind of want to see like the order in which nodes were taken, so that we can do things like see, oh, did we go this way first or did we go this way first? Because then we can get a good feel for if the algorithm's kind of like working as expected. And if that works, then we can start looking at like, it's going to be slow as shit. Our current implementation is bad, and we will have to fix that. But who knows how far we're going to get down this path today. Maybe this is going to be fairly painful. Maybe this will be really painful. Maybe this will be really painful. We don't know, and we'll find out. All right. That's all the background. Apologies for the long explanation, but I think that it is going to be hard to follow if we don't give that. So, hey, camera bitrate super high right now. Yeah, it's because we're capped at 6,000 kilobit, and my GPU is doing the encoding, and it's really stupid. It's not smart enough to do like cross iframe bitrate smoothing. And so what it does is every single iframe, it goes, holy shit, that's a lot of data. And then it's like, what is like low detail that I can like blur out? And my face is like lower detail than the map. And so it's like, oh, we'll blur the face. Which is, you know, it's a little funny, so I haven't bothered fixing it. But I can see how that'd be really fucking annoying if you didn't think it was funny. So, okay, step one. I had gone back a little bit because the map was broken as shit, and so I couldn't demo it like that. So let's go forward, build the latest and greatest, and let's just kind of try to remind ourselves how fucking broken it is. Love this entire thing, and selfishly hope you might be able to adopt this for New York City and various places with public transit options. So I think that I'm trying to avoid hard coding anything specific in the app. I think I'm trying to use the model where there will be pre-processing steps to make things compatible. But like the transit system is using this like generic format, which I assume would map to other cities. The satellite format is going to take like a little bit of massaging if you can find the data. But yeah, I'm trying my best to make sure that like it could work somewhere else, because you know one day I might move. You don't know, and like I don't want to like be like, oh no, I have to rewrite my app now. Actually, that'd be kind of fun, but you know, you get the point. Okay, so he's mad because we have to regenerate the site. The like workflow of the app is that we have like two components. We have this like pre-processing step where we take all of these data sources and we like shove them into like one blob of shit that we can process on our side. And if our blob of shit doesn't map to like the blob of shit that we expect, then he gets angry. So we just have to do that real quick. This guy's leaking like crazy, and that's really annoying. Actually, let's fix that first. Let's fix the leakies. Squeaky leakies get the job done. What's it called? Squeaky wheels get serviced or something. Squeaky leakies get fixed. So fix benchmark app goes here and fix leakies. Because if we control C out of this, then we've hit problems where the file doesn't get like fully generated, and that's a pain in my ass. So I want to fix that. I know where the leak is too, so it's just a really easy fix. It's somewhere. I actually don't know. I lied. I lie sometimes around here. I thought I knew where it was, but I don't. So what we're gonna do now, it says we're gonna run in debug mode, and we're gonna run make site on this like small chunk of shit. So we have like we've got like data that we've pulled out from OpenStreetMaps for like all of Vancouver, but we have like a much smaller segment that we use for like testing. That's for like kind of just downtown. The squeaky wheel gets the grease. That's what I was trying to say. The squeaky leaky gets grease. I'm gonna grease up this wheel. We give up. I give up. This analogy isn't working. You can just exit 0 and don't call defer and report leaks and you don't care. Yeah, but I just want to fix it. We might as well fix it. Yeah, so this is just saying that it's coming from departure time in busdb. Right, because at one point we were returning strings of departure times to the caller, and then later we changed that to parsing the departure time from like hour, minute, seconds into just seconds since midnight. And so we like duplicated the string and then we forgot to free it like dumbasses. So I can just replace it with temporary because we're not trying to store it anymore. And then that should fix it. That should fix it. So let's try that again on the big data set because I'm fairly confident. I'm not fairly confident. I lied. Extract. Oh, is it that this isn't available anymore? I see. I see. All right, let's see if that fixes it on the small data set because I'm not confident anymore. The squeaky leaks get the bug tweaks. There you go, bud. Thank you. Thank you. Thank you. Okay, so that's chilling. That's chilling. No more leakies, and now we run it on the full thing. And that's fixed leakies done. Wow. What a big win already. Look at us go. Look at us go. I guess maybe we have a little, we'll say this will start in 15 seconds. Fix benchmark. Okay, so we have this benchmark app that we use that basically says instead of like selecting 2 points on the map and like drawing between them, we can just hard code some node indices. And we use this to like profile the path planner and try to like improve performance of it. But we can also use it as like a programmatic testbed for ways that it's shitty. And so let's kind of look at how it's broken. We did just comment it out because we're lazy. And I don't know why we did that, but it will become apparent in a second when all of the compilation stops working. Okay. So our adjacency map probably now takes in some information about transit, right? So before we built this map of like, given a current like node in our grid, like a corner or something, who am I adjacent to? And before that was only OpenStreetMaps data. Now we have like transit data to deal with. So let's take a look at that. PP benchmark. And this is, what was it called? Node adjacency map builder in it. So this just needs to take in like, I think it's metadata dot something. I guess we should pull in metadata here as the parameter and then it'll autocomplete for us. Wow. Look at us go. So this is bus node start index. That's what we're looking for. Okay. So now he's mad because this needs to take in a metadata like this. Now he's mad because this is supposed to be strong typed, which is fair. This is fair. Now he's mad because we deleted this right. So before we used to iterate all of the like connections between nodes, and we would say, hey, we have this connection now. We have kind of adjusted this, I think, to basically like we mark connections between transit neighbors, normal neighbors, and like transit to normal neighbors. We kind of like mark all of those differently. And so we can really, this should get pulled out into another like a helper function later. But instead of doing that right now, I'm just gonna fucking copy paste it because we are in prototype mode. We've been in prototype mode for days and it's easier that way. So in prototype mode, we just don't really think and we just do. We do whatever we have to do to get it done. He also needs a way ID value, which I think we are not tracking here. So we'll just say const way var way ID is equal to 0. Okay. I think that's what we want probably. I think this is map data dot, boom. There, okay, so that seems good. Expected 12 arguments, found 8, so the path planner initialization is just totally fucking broken as well. Probably because we added a bunch of stuff to it. So we added allocator, points, ways, adjacency map. So here we need way lookup. Do we have that anywhere? Point lookup, string table, cost tracker. We might not have built the way lookup. Oh, we have it here. Way lookup. Look at us go. Okay, so here we go. Way lookup. Okay, what else are we missing? Adjacency map. Bus trip times we need. Node cost we still have. Start and turning cost, min cost multiplier. So we need path start time, movement speed. path start time, movement speed. This is how fast we walk. And then what was the other one? It was like bus something. Bus trip times right before node cost. This is gonna be, was it a pointer? Fuck. Pointer or value? Pointer. And I already forgot where it was. Pointer before node costs. Bus trip times. Okay, so that means we probably need to construct a bus trip times, which we can copy out of here. Easy. Metadata in this world is called parsed value because we parse it from some JSON. Path start time, I guess, comes in on the command line. That makes sense because, like, depending on when we start, there's going to be different buses available to us. So we'll just kind of huck in a path start time. And oops, turning cost. I accidentally copy pasted that twice. All right, we'll just delete one of those. Okay. Path start time. I guess we'll make it optional. And his initial start time will be like, I think it's seconds since midnight is what we decided. And we'll make it 0 by default. And then if we see the argument path start time, we will set path start time is equal to the parsed argument of the next thing. So we say const path start time s. I guess we have like this thing called getArg. I don't know what it does, but I guess we want to use it. And this comes from process name, I guess is what we did here. Then we say path start time equals std format parse int this time, and it's a u32 from path start time s base 10. We catch the failure probably, and we will complain and print the help if it is not valid. So we'll say this is not a valid u32. Wow, path start time, boom, s. That makes more sense. So path start time s is not a valid u32. Perfect. He's mad here because it's not defined. So this comes from args now, which I think we didn't define yet. What is dot at? Okay, so if I write like variable x equal 4, right? That's fine. If I write variable x equals 4, he goes, what the fuck? That's a string. You're not allowed to do that. I guess this is a bad example. But maybe if I wrote something like x2 like this, right? I want to have like dashes in my variable name. That's not allowed. But if you put an at before it and then put in quotes, now all of a sudden you have like an identifier that can contain anything that you can quote. That's part 1 of this, okay? Part 2 of this is you have enum is like an enum of like A, B, and C, right? We'll call this my enum. If I then say enum like instantiated is an enum, I can say that this is equal to dot A, right? Because this is like a field in this enum. So we're combining these two things together so that we can have like options is an enum. I think it's like this, sorry, lowercase. And the enum has like identifiers that match like a argument that we might want. The reason we do this is because in Zig you can say std meta enum to string or something, string to enum, right? So you can actually take a string, check if it matches any of the options in the enum, and you can like basically like iterate the enum there's like compile time reflection kind of, so you can like basically generate some code that will walk the enum and check if the content of the enum matches the string. And then from that, you can do like a switch on this enum that just came from a string. It's like this like rudimentary way of doing like string manipulation of string matching, where instead of doing string matching, you like convert the string to an enum, and then you can use the enum, which is just numbers, in a switch. Little aside, but I think that's like a fun little trick I like discovered. Discover is strong. Like, what's it called when you like I didn't like I'm not the first person to do this, I'm sure, but I like stumbled upon it by mistake at some point. I was like, oh, that's kind of cool. I like it. Okay, so our path start time needs to go into here, and then down here path start time is equal to path start time. Boom, boom, boom. Oh, so movement speed doesn't work yet, and I guess movement speed comes in on the command line as well. That seems reasonable to me because both of these things are things that we might want to like adjust. A hack? I mean, I don't think it's, I'm more thinking like, you know how people think like math? I think math isn't real. But some people think that math is real and we just discover it, right? And so if you like just stumble upon this thing, it's like this thing already existed, but we just found it. And so that's kind of what I was thinking. It's like I like discovered this thing. by like accidentally doing it one time. You know? This is a float, and we're gonna default this like 1.2 meters per second or something. And we just copy paste this. Movement, speed, and then here, everything that says path start time gets like movement, speed. This is a float now, so this is parse float. Floats are always base 10, and this is not a valid F32, chilling. Now we just have to like, we have this here, chilling, and movement speed goes here. Movement speed is equal to movement speed. Boom. All right. So hopefully this at least fixes some of our compile issues. Maybe not all of them, but maybe some of them. Switch must handle all possibilities. So now he's mad that in help, we haven't tackled some of these new things that we added in, which is great for us actually. So we'll say path start time, I think was what it was. And the other one was movement speed, I think. Here we'll say the path start time, we will write movement seconds since midnight and optional. And then the movement speed we will get meters per second optional. Boom. Always base 10. Have you said the base 16 float literals? Really? I thought that the Zig format doesn't have it as an argument, so I was surprised. Float literals. Underscores. Float literals. I don't see anything that says base 16 here. I guess that's what this is. What the fuck? What is happening here? This is all decimal, but it is hex float. Interesting. I've not seen that. Okay, well that's fucked up. I don't like that at all. I don't like that at all. Okay, so I think everything else seems kind of chill. Does this build now? No, he's mad at access of union pointer when struct is active at 312. Alloc free path. Oh, right, because the return type of path now is not just a list of nodes, but it's also a duration of how long it will take to get there. So here we want to actually call now path dinit with alloc. Boom. Okay. Is that it? Let's go, baby. We build. And now let's try to like construct some sort of test that we want to run. So, did we run make site? I think we did. We did. And so now we should be able to run like zig out bin map of output. And I guess we'll just kind of see what happens. So we just want, oh fuck, that's annoying. Where is that coming from? Max lon, min lon. Max lon. Where is that? That's an annoying ass log. Get the fuck out of here. Get the fuck out of here. Zig build and. All right, he's thinking. Who knows what's happening? I don't. It's probably pre-processing a bunch of stuff that takes a long time, like the transit stuff I think that we saw took a while. Some of like the parenting of streets took a while, but that's gone. I'm gonna just rebuild this in release mode because this is annoying. Optimize equals release small. I'm pretty sure that this wasn't what we were seeing yesterday. I'm pretty sure what we were seeing before was that the map opens, but the path planner was slow as shit. If we can't even open the map, then we've got another problem on our hands. All right, that's better. So let's kind of just try to do a path plan that doesn't involve the bus at all. So we can do something like, we had a test case over here somewhere yesterday, right? Like we like this is kind of easily identifiable. So let's go from actually there was like some docks over here that were just like straight line. It was this one was the one we were looking at here. We were looking at 254076 254076 to 254080. 254076 254080. Okay. let's just kind of see if we can see if that plans like a reasonable path with our path planner benchmark. So zig out bin pp benchmark. We have map data bin comes from output. Map data bin. Map data JSON comes from output. Map data JSON. Nice. Start ID. We want it to do 254076 to 254080. Num iters. Let's just do this one time. Turning cost is 0. Movement speed is optional. Path plan start time is optional. Attribute cost we don't need, so I think it's like this. And this is the behavior we were seeing yesterday, where it just kind of freezes up. This should be like almost immediate, right? We should like this walk is like, what did we like? It was literally like 2 nodes or something, right? And there were 2 nodes with no branches available. So what the fuck could it possibly be doing for this long? Obviously, whatever it's doing is a fucking bug. And now we can kind of work on this without having to like spawn the app and find the locations and drop between them. See, now he's saying that there's no path from those things. That's insane. Of course there's a path between those things. So now what? Fix benchmark app, that's done. And debug massive slowdown. Let's do that. 2625. All right. So I guess we can start by just kind of like going into the path planner and just logging all of our moves. That seems reasonable to me. Seems reasonable. So maybe on each step, we can do like a node ID is current, we'll do it here, is a number. It's a number, and it is me node ID. Let's just kind of see. We do have to build the app if we want it to do what we want it to do. So we will build it. And he's actually going to get mad. That's surprising. Probably because D is not a valid thing for a strong typed thing. We have to look at the inside of it. You got to look inside. But not in like a weird way where you're like taking apart his body and looking at his stomach. Just like, you got to look inside a little bit. Okay. So maybe let's limit also the like number of iterations to like 10. If I is greater than, less than, or greater than, or equal to 10, greater than 10. I don't know, man. Break. I guess we'll return error. Early exit. All right. All right. Let's see what happens here. So 179417 is the first thing he looks at, which just seems like it's like totally wrong. Right? That's I think that we should see nodes. I think it's just like we're indexing incorrectly. We probably fucked something up. We almost definitely fucked something up. The question is why? Why? So let's just double check if we open the map, which I think we did with this command before. Let's just double check that that is not a neighbor of the node we were looking at. So it was over here, like kind of like a path into the sand was this one, right? 254076 goes to 254074 8180, right? So we're just not looking at the right neighbors. Oops. And the question is, why the fuck? I guess we start this. These are the neighbors where we expect these to be our neighbors. So let's look here. GDB args. No, we'll run pp benchmark and we'll run this under GDB like this. And then we can break on this line and run. And we'll just take a little peek skis. So we can look at, well, that's not where I wanted to stop, was it? Oh, maybe it was. It was. I can't remember what I typed. So what's in our neighbors? So I think you can do dereference this thing for 3 times. And so this gives us, this sure is the number that we saw logged here, but it's definitely not the number that I want. Is me node ID right? This is also not right. So we're doing something fucking brain dead when we're trying to look up our current node. This was probably a mistake in updating some of our like score storage format. We needed to kind of like swap some directions to make it so that it worked with unidirectional connections, right? So before we made this assumption that if like I was a neighbor, A was a neighbor of B, that B was a neighbor of A, and that's not true in a bus route because buses are only move in one direction. So if we consider like our edges of the graph to have like direction to them, then we had to like swap some stuff around. I think we just fucked that up. So this is like just brain dead, whatever's happening here. And yeah, this is just, we know that this is wrong. We fixed this at some point, and we just must have lost it in our like cherry pick / rebase. So if we look at what I'm going to assume that this is, we have like a sentinel value that says we came from an adjacent node. Why the fuck? Okay, let's start here. What the fuck is this for? A star. A star, we have scores stored for each node, right? So if we're trying to get from like here to over here, we'll add some stuff to the grid. We store like kind of like the cost of movement. So this is like 1, right? This is 2. If we get to here, it's 3, and then this is like 4, right? Now our version of A star is a little fucked up because we have like this concept of a momentum that we added. So like we want it so that if we go like this, that's a bad example. Let's see. We want it so that here, let's kind of like we'll draw something new because it's easier to draw like this. We want to make it so that this movement costs more than this movement. And so in order to do that, we kind of have made it so that our nodes kind of capture two things at once, so that we can kind of say, okay, so these two nodes coming from these two nodes have a score of this, but these two nodes coming from these two nodes have like a lower score. So all of our A star implementation is in this like dual node space, which is kind of weird. And so here we're trying to convert that dual node space into like a specific neighbor thing, kind of hand wavy. So probably if we breakpoint here, we will see something fucking stupid. So nodes, and not nodes, but edges instead. Yeah, we've kind of made our edges nodes, and so we have like our edges in our graph are like pairs of, are like edge connections to other edges, I guess. So we should see that like, so okay, all of that to say, on the first, when we first start path planning, this is the first node, we didn't come from anywhere. And so we kind of set a sentinel value on some of our like offsets in here. And I think we're just not like correctly, we're not like respecting that sentinel value. So if we look at like current node ID, no. Info locals, what are my locals? Where the fuck am I? I'm in step at me. So p me node ID, that's allowed. But here I can't p current node ID? Why the fuck not? Oh, that's so annoying, GDB. I'm even in debug mode. That's crazy that that's not allowed. But I expect that, I guess maybe we'll breakpoint one line back. No, we have to breakpoint. Like if we breakpoint here. Is it just, like it shouldn't optimize this out in debug mode. That's crazy. That's so frustrating. Well, I guess we'll just have to do it through code. When we initialize this thing, we found this yesterday when we were implementing this. We start like me is like a sentinel value and came from is the start. And so we have to say here, before we index with those things, we have to say if current node ID dot me value is great equal to 0xff and current node ID, oopsies. Current node ID dot came from is equal to self start. If these two things are true, then it's one thing. In this case, we are just using start. But otherwise, we use this thing that we are indexing like this. And that should fix it. It should fix at the very least one problem. Who knows how many problems it will actually fix, but it'll fix the first one, hopefully. So now we see that we start at 254076, which is a good sign, but the next node it still looks totally fucked, right? We expect it to go like, yeah, there's still something wrong here. So it must be that even though we got that right, it's still the other case, the case where we're indexing is still wrong. Which it does kind of look like that is wrong, actually. Now that I look at this, we're supposed to say like const start is this, like, I thought that we fixed this. Feels like we've already done this, but maybe I'm misremembering. So this should be segment starts at this. End is this plus 1. Or I guess, what is this? Wait, hold on. Segment starts. This is neighbor. This is index, I guess. Yeah. And then this is index here. So we say, give me, I look at the came from value in segment starts. Then I add this thing after that value. Yeah. So with the storage format is like, you have like nodes 1, 2, 3, and then you have these are like neighbors for node 0, and then for node 1 you might have like 2 and 4, and then for node 3 you might have like 5 and 7 or something, right? We store like the index of this, and this in another array of like 0, 1, 0, 4, 6 something. 0, 1, it's 3, 5, I think. 0, 1, 2, 3, 4, 5, yeah. And so then we know we index into this array to get where we start to index into this array for that node ID. So we say, okay, we are coming from this node. The neighbor start index is going to be here. Then we add in this to index into this other array. Boom. Hopefully that does it. Hopefully that does it. There we go. Look at that. 6, 5, 4, 8, 1. Okay, so that's a really good sign. That's a really good sign. Now let's see if we can use this to actually see, like, plan a path at all. Like, what happens if we run like the normal application? Release small was this is the build that we do where we have relatively fast compile times, but still relatively fast execution times as well. Okay, so let's go back to that little, where was it? This path here. Okay, it's slow as shit, but it does at the very least plan down here. That's good. We are early exiting. That makes sense because we did not delete the early exit, so we just shouldn't do this anymore. And holy crap, this is slow. It's because we are now like trying to like figure out every single bus stop, which one's closest to us for every single node. And the way we do that uses no intelligent like searching. It just like fucking brute forces it on every frame, which is not good. Okay, so it does. Okay, if we could like debug path planning. Oh, that's a really good sign. Look at that. Look at that. Look at that. So, I wonder if we can like, ow. End path planning, please. Okay, so if we like go here, right, and we start moving up, he does like kind of go here, which is good. It would be interesting to see like if we like go kind of far from any path, like any, how do I say this? So that, like we want to go far from any but one bus route. So I guess if I'm like here and I want to go like over here, that's really good. We see it go to the bus stop first. That's really good. That's like exactly what we wanted. Ow, it's so slow. Ow. But that's a good sign. It's a good sign that we're like on the right path. Okay. So I think we know that the transit calculations they're not you doing the right math. So let's kind of fix that, and we'll see that if we fix that, if we start to get like what I would consider sane routes, they'll be slow as shit to calculate, but it'll be interesting to see if they're sane at all. Right, so we started hooking this departure time thing. Let's look at that and see if that's right, because we never saw evidence of that working. I also want to go into native GLFW and make sure that we have debug logs on all the time. It's like const std options is a std options is equal to, I guess we can kind of do it like this instead. That makes more sense. And we have like log level is equal to debug. And then we can do this. We can do this. And I want to see if we can, we just want to see departure times getting logged at all, I guess. So if I go like this, I'm not seeing any log saying departure time. Std options need to be pub. Good point, good point. So it might just be that the logs aren't even getting shown, but we are logging something. Now we do see some debug logs. That's a good sign. Good sign indeed. And let's just go back over here and try to like hit a bus stop somewhere. I don't fucking know. Oh, I think I saw some. Leaving at. So this gives us all of the times that buses will leave at a given stop. So that's a good sign. Great sign. Great sign. Or neighbor leaving at. Is that? Yeah. So this tells us when the bus will leave, which is very good. That's a critical piece of information. Critical piece of information. Std log debug. I don't want this node ID log anymore. And I probably don't want this anymore either, to be honest. Update transit neighbor. So this says, hey, I have a neighbor. I don't really know what this does actually. So the purpose of these update neighbor functions is to update the costs of all of my neighbors and re-queue them into the A* list of nodes that we want to process with their new like heuristic scores. Do I look at all of their neighbors? So I look at me. And I update every single one of my neighbors. Right. So it's like we go from here to here. We process this node. He's got this neighbor, and we have to figure out this cost as well as their heuristic distance to the end. And then we re-queue them in the node as like potential next things to look at. And then whichever one has the shorter distance to the end, we'll look at next as me. Okay. That makes sense. So when we update transit neighbor, we now want to basically adjust the costs to use this leave time, departure time. So this is surely going to have to come in here somewhere. So we'll just kind of do this. Sure. And he is going to have like his departure time as a U32. Then instead of this like bus multiplier thing where we try to calculate the distance between us and our neighbor and use the bus multiplier, instead we just want to say like, the tentative score is going to be departure time. So it's going to be departure time minus now. So we have now. Now exists. We have this as like current. We do have this. We have this somewhere. We tested this yesterday. It's in our A* node. We store. We store it somewhere. I just can't remember. Next to F-score. Here. Node with F-score. We store time elapsed. So we need to say the departure time. Departure time with the cost to get on the bus here to get to the next stop is going to be the departure time minus current time. That makes sense. So we need to get the current time, which I think that we just pass in here somewhere. surely we have this. Me node ID comes from like current node ID dot time lapse. Here we go. So we'll call this current time is a U32 departure time. So we have departure time minus current time is const cost is equal to this. This is not a node cost. It's actually like a cost multiplier. So we don't have bus multiplier anymore. We just have the cost times the cost multiplier. That makes sense to me. Now, when we calculate the heuristic here, we have our tentative score. That makes sense. Time elapse equals previous time elapse. So time elapse is now just going to turn into departure time minus self start time. Oh, which means we probably need a start time here as well. So this current time is like how much time has elapsed since the path start. This is in like absolute time. So this needs to be like departure time minus path start time is going to be the amount of time since the start and then subtract the current time. That makes sense to me. Now we have some tricks here where like the departure time might be before this thing. So we can say like if departure time is greater than path start time plus current time, I guess if it's less than that, we just kind of say like fuck it. We're not going to use this thing. So we don't have to calculate any scores. We don't have to like queue it. We just say fuck this shit. Fuck this neighbor. We don't want him. Which I think makes sense. I think that makes sense. And then here, the F score of our neighbor is, I guess, going to be this like heuristic distance. The same as in the other version. And then multiplied by the min cost multiplier times the movement speed. That seems right as well. And we should like maybe like fix me. There's already a fix me here, perfect. But like fix me, no, for real, it feels error prone as shit. There, double fix me, I can't miss it. It's impossible. Then the time elapsed for this will be this, but the cost, we need to multiply the cost by the cost multiplier. Oh, we do that. Wow, look at us go. We're so smart. Yeah, okay. I don't see any major issues here. I don't see nothing's jumping out at me as like clearly wrong. There's lots of things that I'm looking at this and I go, I don't really know what's going on. In fact, the whole function I'm looking at and thinking that, but we're not going to admit that because then you guys will be like, holy shit, he's dumb. Fuck. Unused function power prev time elapsed. Ah, right, because before in like the other version of the function, we say, hey, we took like n time to get here, and then like we add on the time it takes to walk this path, and we add those two together, and that's the new time. In this scenario, we actually just like, we don't care how long it took to get here, as long as, oh wait. Prev time elapsed is just the same thing as current time. I'm an idiot. Prev time elapsed. We just do this. I was going to say that we don't need this, but we do need it, and I'm just stupid. Which means update transit neighbor must be passing in time elapsed twice, and he is. So this just goes away. Oopsies. And U32 and F32 don't add together nicely. Okay. Departure time is U32. So I guess this just gets like rounded up. Right? We're trying to say like if the bus leaves before we get there, we want to make that more likely, which means that we need to make the previous time elapsed bigger. So we round this up. Yeah. Is there like a round up seal? Yeah. And does this convert it into U32 for us? Or do I still have to do float from int? Probably do still have to do float or int from float. And fuck this line of code. There we go. He's also mad. So cost should be a float. So here, this time path start time gets cast to float from int. And this gets as F32. And is period time elapses of F32, that's fine. Departure time is also as F32, float from int departure time, and we'll just kind of copy paste this. Usually I try to like pull out variables for these because it makes it like this is just impossible to read, right? You look at this and you're like, what the fuck am I looking at? At least maybe you're not thinking that, but I'm thinking that. And this code is for me, so really I'm the only opinion that matters in my own code base. That's a fuck this. Okay, well, you know, we're gonna do it. So here we have departure time needs to be. We'll just say like const departure time f is f32, which is this, and then that makes this easier to work with. Departure time f, boom, and then this is departure time f over here. Really? Time elapse is an f. Oh, path start time also needs to be an f. Path start time f is float from int self path start time, boom, and then here this is also path start time f, which makes this also path start time f, boom. Give it to me, baby. Come on. I guess I should say give it to me, baby. I'm saying like, you know, I want this to work, but I guess like the connotation of that phrase must not be good, right? There's no way that I'm saying give it to me, baby isn't problematic. So I just have to be careful with my words sometimes. Okay, so what do we expect to see now? I guess we expect to see that we take the bus if there is a bus scheduled at the right time in the right direction. So here I kind of walk, I walk, but maybe if I get far enough away, it'll start taking the bus. Right, like here he's fuck off. Okay, so I'm losing mouse release events if I move the mouse at the wrong time. Because every frame we're doing all this shit inline. And then okay. So let's start this kind of like midnight is like a bad time for the bus. So can we kind of set this? Oh my fucking god, I'm gonna lose my fucking mind. Okay, let's try again. We'll try again. We will set the start time early. Mid time's a bad time to take the bus. Let's kind of set the bus time at like like I don't know, noon. Maybe even like 3 o'clock is a better time. So we can say like 3 o'clock is 15 hours since midnight, times 60 for 60 minutes, times 60 for 60 seconds, 54,000. So 54,000, right? We want to see at some point that like if I try to go from here and I try to go up, eventually it should decide that it's better to take the bus. And so like, well, let's at least turn on debug path planning. So this is kind of working to some extent where you can see him kind of like going towards the bus stop. Who knows if it's actually working actually, but it does look like he's trying to do that. Now, oh yeah, we are also seeing, hold on. So how is this happening? Fuck! I'm gonna lose my mind. Let's try to, instead of doing whatever the fuck we were just doing, let's try to run it in the path planner benchmark and see if there's anything that we're doing that's like really fucking stupid and dumb and stupid. So we can do this again, but let's just try to like maybe pair a couple nodes and see what happens. You have a cool project. Thank you. I also think it's cool, which is why I'm doing it. It's fun for me. So let's go from 448599. 448599, and let's just kind of go like all the way over to like here. 439511. Now, if we do this at the right time and the number 7 bus shows up, we should end up taking the number 7 bus down Dunbar and Alma, and we should end up over here. We should end up over there. So pp benchmark. Let's run in release safe. let's try to go from start ID 448599, and we'll try to use 439501. One iteration, no turning cost. Let's just fucking run and see what happens. He's got to think because he's got to compile and link and optimize all of these executables. I will say there's one thing about like the Zig build system. The Zig build system is pretty sick. But there's like I don't really like how in Make and like CMake and like Ninja and all of like the other build systems, it kind of like generates targets for every single individual thing that you build, and then you like have like a collection at the end. I don't think the Zig build system has an easy way for me to be like only compile this one artifact. Maybe it doesn't, I just haven't looked. I'm kind of curious now. Can we say like, because you have like these are like our steps, right, that we can do. We like attach artifacts to steps, but can I build like a specific artifact? Yeah. Not really, huh? Not really. That would be a nice thing to have. A nice thing to have. But I guess like you could argue that in my build script, I could just automatically expose that somehow. You can probably walk the build graph and like figure out what all of the things are. Like in fact, in our build script, we have this thing already where we have this install and check where we say, hey, install this artifact, but also like make like a fake version of that thing. And you could probably also be like, create build step from this artifact. Make a run step for that artifact. Does that not work? Yeah, but it's like, it's just in Make, you get it for free, right? I didn't want to have to do the work of like making every single step its own artifact. Can you just use a separate step for each one? Yeah, you could. I just don't want to, like, it's more about like the effort that takes on my side. Especially like if you have like this might be different in Zig land, but what's actually really nice is in like if you have like a C++ project that has like 1,000 elements, 1,000 object files that get compiled into like 5 libraries that can compiled into like 2 executables or something. What you can do is you can like find the build flag for one of those 1,000 objects, and you can just build that thing over and over again as you're debugging, which is like a kind of nice thing you can do. I don't know if there's like a way to like kind of hook into the build system at that detail in Zig without just getting into build script. But then maybe like the model, maybe they're saying like, well, if you have a system that's as intricate as like, that works as simply as Zig's build system, then just fucking make the artifact, right? Like you can figure it out, which, you know, is pretty reasonable, right? Because like part of the pain of Make is that like it's shit to work with, and so you wouldn't want to make a new step for each thing because it's just like fuck working with Make. So I don't know. I'm talking at my ass. I don't know what the fuck's going on. Classic me. Okay, anyways, why was I talking about that? Because I wanted to run the path planner benchmark, and it just took a little bit of time to compile, and that bothered me a little bit, but that's okay. Okay, so this is path planning something. We don't really know what path it's taking, so maybe what we should do in our path planner benchmark app for now is we can like log the path. Isn't incremental builds are working on just that? Maybe, I don't know. I don't know. Can we just do like std debug print node? Sorry. Planned path is nothing, so this is path.path. And if we see in this planned path that there are node IDs that are really big numbers, that means that it decided to take the bus. Because we have like a block of like OpenStreetMaps IDs, then a block of bus IDs. Instead, he's fucking angry at me because there's a segmentation fault at node.value. What? That's a good point. If I free the memory, I free the memory. And I'm so tired of these compilers and these operating systems getting mad, doing what I say, right? I really want them to do what I mean. That's not actually true. It pisses me off a lot when things don't do what I say. But you know, a little bit of me kind of wishes. So I believe that this is not taking the bus, just skimming these bus numbers or these node IDs. We could actually get a little crazier here, and we could say like if we could say we could say like if node value is greater than or equal to metadata parsed value is what it's called in this scenario, and the first bus node index. Then we could say we took the bus. Took bus. I guess instead what I want to do here is I want to say like var took bus is equal to false. And we can say took bus is equal to true, and then break. And then here we'll say took bus, and we can do like took bus like this. And then it will tell us if we took the bus or not. How can you be mad if it does what you want, not what you said? Well, it pisses me off when, because I don't think anybody knows what I want, including me. And so anytime a language tries to do that for me, then I get angry. Took bus, false. Okay, so the question is, why not? There could be a couple of reasons, right? One could be that it just happens that walking there is actually faster than taking the bus. So I wonder if we like really reduce our walking speed to the point where it's like unbearable as fuck, then it's more likely that we take the bus. So we can say that like our movement speed is like 0.5 meters per second. Still does not take the bus. Okay, and we can maybe like ask it, how long did it take? So trip took this many seconds. And this is going to be the path time. Okay. Give it a sec, he's thinking. He's thinking. So it took, what is that in minutes? 21 minutes? If the bus comes every half hour, that's not crazy. How is it that this trip took 31 minutes only? Where did I tell it to go? I thought I told it to go like kind of far. That's what I remember doing, but maybe I didn't. So I thought I was telling it to go like, I'm not going to be able to find these nodes. It would be nice to kind of like, we should add some sort of feature to the UI to punch in a node ID and jump us there. But instead, I'm not going to. So I think we started like somewhere over around here, 448606. We're like in the right kind of ballpark. I guess we should like pick things there. I guess this is like, what street is this? This is like 36th, and we went down to like somewhere around here. So this was 36th to like 13th. So 20 minutes isn't crazy, but with a walk speed of 0.5, that feels very quick. Let's try to pick some like rememberable node locations. So maybe we'll start at 448940, which is right in this corner here. 448940, and we'll go all the way to the beach. Like all the way, I think this is where the 7 goes. This is 4th Avenue, I think. Yeah, so the 7 goes down Dunbar and then turns here and then goes downtown. So if we get off like here, certainly we should take the bus. Even if we go all the way over here, we should definitely take the bus because the 7 goes all the way over here. So let's try to find, we'll go to intersection here, right before McDonald Street. So this will be 408589. Okay. So we just want to change these to go 448940 and 408598. And he still did not take the bus. And he took an hour to walk there? Let's just like fucking like reduce movement speed even more. Our movement speed's backwards. Wasn't it 589? It might have been. It might have been. But either way, we're multiplying by movement speed. So that's probably pretty fucking stupid. We should be dividing by movement speed. Certainly. Because our movement speed is supposed to be in meters per second. And so if we're trying to get seconds and we have meters, we need to divide by this. right? Because like you do your little unit conversion. Meters per second times seconds goes to meters, right? Because like the s's cancel out. So if we have meters and we're trying to get to seconds, we need to use a unit that divides by meters and multiplies by seconds, which is the inverse of meters per second. You guys are claiming that I fucked up, so let's just double check the node IDs because I might have written down the wrong thing. You guys are attentive to detail. I will say that's one thing that like my whole life I've struggled with is my attention to detail is really bad. Like really bad. 859. 859. And was 940, right? It was like in the corner here somewhere. I think it was this one. 448940. Yeah, okay. My attention to detail has like always been so bad. In my I remember in physics 11 or physics 12, I can't remember. I wrote my final and I went back to school for like to pick up something later, and like the physics teacher was like there, and he saw me, he's like, come into my office. I'm like, what's wrong? And he's like, you got like an A on this test. And I'm like, great. And he's like, you missed a page. And I'm like, that's crazy. Like, he's like, why did you hand this in and not do a page? I'm like, I don't know, I just didn't see it. Like, I just didn't see that, but what do you want from me? Like, it's not like I intentionally didn't do the test. He's like, what the fuck is wrong with you? I'm like, yeah, I've done this like my whole life. What do you want from me? So, things like typing in the numbers right is like, ugh. That's why I'm like, I know that I would be awful at QA. Like, anytime I have to like run a bunch of experiments and try to like remember what I did for each experiment, even if I like write it down, I'm just like fucked. I'm just like, I don't know what the fuck is happening. Okay, so let's run the path planner again. And this is supposed to be 859. And our movement speed now when we go down makes it take longer instead of shorter, which is a big win for us. Huge win. All right, baby. I want to see us get on the bus. Took bus true, baby. Let's go. So taking the bus took 20,000 seconds. 2531 over 60. So 300 minutes? There's no fucking way, right? 300 minutes? That's 5 hours. Obviously, it's not going to take us 5 hours. That's insane. 6 hours. That's fucked. That is absolutely fucked. So there's something wrong here for sure. For sure, there's something wrong. I wonder what. What if the bus blew a tire? Yeah, but the bus blowing a tire shouldn't be in the bus schedule, which is the only piece of information we have right now. Bus had a flat. Yeah, you guys are in sync. So in sync right now. We are multiplying by movement speed here as well, which is again wrong. Really, we're multiplying by movement speed all over the fucking place, which is bad. Which is bad. Movement speed. So let's make sure that we get all of them. This should be divided. Now everything is divided by movement speed, which is much better, much better. So maybe that's almost certainly related. So probably we were just trying like the wrong fucking nodes in the wrong order and then just like not getting there, I guess. Who knows? But maybe. $25,000 seconds, is that the same? That's even longer. That's fuck. Okay. So let's go back to, I guess maybe if our movement speed is so unbearably slow that we're not making it to the bus stop for a long period of time, that might have something to do with it. It also could easily have something to do with this, our like filtering of when we should get on the bus. So, and almost certainly we there's a very high likelihood that we fucked up like manipulation of time units relative to the start of the trip versus time units relative to the start of the day. We certainly are fucking those up all over the place as well. So let's just be fucking careful. I forgot to answer whoever asked when I started coding, and that was a long time ago. I've been programming since I was like 10 or 15, like 10 a little bit. We did like a coding class with my dad where we worked on like Hangman and Sudoku solvers in Visual Basic and Excel. And then I took a bit of a break, and then I started to use Linux because I wanted wobbly windows, and that really fucked with me. Because you can't use Linux without coding; it's impossible. So we've been going for a while. Do you have any thoughts on Mapbox? I've used it as a service before. Sounds familiar. I'm not a fan. I'm not out here trying to use services. We're out here trying to write our own shit from the start, from the ground up. Fuck tying anything we write to a service, right? The concept of services just means that like your shit's gonna break later, right? And so like, I'm not a fan. I'm not a fan of services in general, but it's kind of like fucking stupid. Of course, in the real world, sometimes you use them, but we don't live in the real world here. We use it. What was I fucking talking about? I already forgot like the words I said 3 seconds ago. We don't live in the real world. We live in a fake world where I can do whatever I want. The benefits of writing code for stream versus writing code for a company is that it actually doesn't matter. It doesn't really matter if we ever finish anything or do anything of value. It actually matters more if the thing that we're doing is interesting, which is kind of funny. It's like this weird fucked up incentive that aligns better with what I like, which is kind of fun. You get to make bad business decisions for fun. Isn't that fun? I think that's fun. Plus, you're not getting paid for it, so that's great. Yeah. Another big win for me. Okay, what the fuck were we trying to debug? We were trying to debug the fact that it's taking like fucking 7 hours to ride the bus. So maybe let's log when we get to the bus. When we get to the bus, it'd be interesting to know what time that is. So here we can see like got to the bus at this time. And this is going to be current node ID, time elapsed. And Andrew really, really wants me to use the time formatter, and I'm going to keep not using it, and it's going to keep pissing him off. Should be stood log debug. Bro, most of the time I have no idea what the fuck you're doing, but still fuck with you. I guess that means that I need to do a better job explaining as I go. I try a little bit, but it's a little hard. It's hard. So I'll try, we can go into more detail. Big frowny face from Andrew. Sorry, man. What do you want from me? So here we actually didn't get this ever. How's that possible? How is that possible? In order to get on the bus, we must at some point get to the bus. Right? If you get to the bus, you get to the bus. Oh, in PB benchmark, we don't have the debug logs on. We need to turn this on in every application. So this is pub const stud options is equal to stud options. Why is this not auto-completing? Hello? Hello? Why the fuck not? There we go. Sorry, I've been ignoring you a little bit. I think you asked, do I like puzzles? Then you asked, have I played The Witness? Because I didn't answer that. It depends on what type of puzzles you were asking about. I hate jigsaw puzzles. I think they're boring as shit. But I did play a little bit of The Witness. The Witness was very fun. I didn't finish it, but I did have a lot of fun with that. I like puzzle games. Puzzle games are probably like the top of the list of single player games, but the single player game list is actually like very low. Jesus Christ. Neighbor leaving at. Okay, let's get this shit out of there. I really much prefer, I've talked about this a little bit before, but a part of me, I know this is wrong, but a part of me thinks that fun is zero sum. And so for me to have fun, somebody else has to not have fun. And so I don't really like single player games that much at all, because I like asserting my dominance in multiplayer games. So a lot of these are pretty big numbers. Got to the bus at big ass number. As PB benchmark using PoopZig are completely different things. We sometimes use PoopZig on the benchmark app, but sometimes not. So I wonder if like we up the movement speed, you'd fit right into Dota League Legends. I played a lot of Dota, man. I've played a lot of Dota. what a fun game. I had this script that I would spam that would back in the day they fixed this eventually, but you could basically like the equivalent of ANSI escape in your chat messages, and you could like put in like rainbow text and stuff, and I would do all sorts of shit to like basically spam wrecked puns at the press of a button with like, crazy formatting, and then I would just click the button every single last hit. I don't know. I'm sure I got muted all the time. In fact, I know that I got muted like publicly by the game a lot of times. But holy shit, it was fun. The fun of the Dota is not to win the game, but to tilt everyone, including your teammates. Well, I always was of the opinion that if you can keep your teammates happy and tilt the other team, it doesn't really matter if you're even playing the game. You could do anything you fucking want, and you'll rank up, because just tilting them and keeping your team off tilt is like that's worth more than one full player, which is so funny. We're just like, what a funny little game. Okay, what was I doing? Got to the bus. So some of these things we get to relatively quickly. I would think that we should get to the first ones pretty quick. 2,000 seconds is a long time, but our movement speed is also really fucked. So let's try to take the movement speed back up a little bit and see if we get to the bus at more sane times. Okay, so these are much more reasonable. They're still quite high. I would still think that like these first ones should happen like almost immediately, right? Got to the bus at 200 seconds. I guess that's maybe reasonable. 200 over 60 is 30 minutes. Okay, so if I'm going from like, oh my god, I opened the calculator like 40 times. So, release small. Let's just try to see like where was I starting this again? I think it was like by Marine Drive and Dunbar. We were like over here somewhere. And he's saying that it takes us 3 minutes to get to the bus. So that's here. 3 minutes for long block feels long, but at 1 meter per second, maybe that's reasonable, right? We kind of saw that like the Google average time was like my metric is usually like I try to get through one of these short blocks like once per minute, but I walk kind of fast. So 3 minutes here isn't crazy. It's not crazy. So he's probably getting to this bus stop pretty quick. And then he's then still taking 4,000 seconds, which I can't remember if that's sane at all. And we should write down in time, but instead I'll just fucking do this again. So it's 4,900 divided by 60. That's 81 minutes. Still way too long. It'd be interesting to see when we first... Can we like log the trip and see which nodes we take? We should log the trip and we can see like if it's taking the Dunbar buses. That'd be kind of fun. So here in PB benchmark, we can say took bus, and let's just log the whole path. So for each, so we won't do this anymore, and we'll just kind of say like, I guess let's just log the node value, I guess. This seems reasonable. Seems reasonable. Oh, oops, wrong application. Wrong application. That'll do it. That'll do pig, that'll do. I think that's Babe, Pig in the City. VHS, I had on VHS back in the day. Interesting. So actually, it does not look like... It looks like it only chose to take the bus like for like one fucking stop. Is that true? We should log the bus node start. Is the parsed value bus node start index. Isn't 200 seconds 33 minutes, not 3? I think I changed it to 3 because no, it's 3. It's 60 seconds per minute. right? So 60 times 3 is 180. I think my calculator said 33, and that's because I forgot to type a 0 in 60. So I just did the last part in my head like a fucking dumbass. Yeah, so I would think that the vast majority of the nodes walked should be above 60,000 because it should take the number 7 down Dunbar. But that's not happening. So, in fact, why does it think it took the bus at all? Oh, he doesn't. Right, we didn't take the bus here. So let's go back down to 0.1. And so here, he's walking kind of like a few nodes, then he takes the bus a little bit, and then starts walking again. He takes the bus a little bit more, starts walking again, and takes the bus a little bit more. It's kind of interesting. Kind of interesting. I wonder, this path planner time is 2.5 seconds. So trying to plan this path with like the current mechanism is going to be a bit of a pain, but I would like to visualize it a little bit. I wonder if there's a way to do that easily. Okay, let's kind of put like a pin in this, and let's try to visualize path planner step by step. I think that'll actually be very helpful, right? If we can step it piece by piece, then we can like kind of make intuition or like get intuition about why it's not working. And it will also let us like visually debug or like just visualize what's happening a little easier, which will maybe be just good in general. So let's do this. So what I want to do is I basically want to convert the path planner to kind of be like this thing that like lives in the app long term. Right now, like on mouse move, we like construct a path planner and run it to completion immediately. But instead, I want to have like a button I can press to step it by 1 point. So I don't really know how to do that yet, but we'll figure it out. And I think what makes probably more sense is to not do this on the transit branch. So let's do this. Git commit-m smiley face, and we'll go back a little bit to like here. We'll do rebase-i back a little bit, and then we'll just kind of like edit this commit, because I just think it will be easier to work with before we've made all these changes, and then we'll get a bunch of other stuff for free. Like when we rebase, it'll land on top for free and it'll be fine. So app zig, we should be able to kind of say like, hey, maybe we have some path plan in progress. So this will be like a path planner. He's gonna start it null. And then on mouse move, we will basically set up the path planner, but we might not run him, right? We'll do like self path planner is equal to this. And I guess we'll say if self path planner, we have to dinit self path planner dinit. I guess we'll say if self planner like this, right? I guess we should do this only if this succeeds though. So we'll say const path planner is equal to this. If self path planner is alive, we dinit the old one and replace it. Right, so it's just self path planner equal to new pp. And then what? Then instead of running it, sorry, I'm just trying to think for a second. I don't really know how I want to handle this. We can say like run for 1 step. So how does the thing work right now? Path planner. He has a run function we intended on it being like this from the start, where like we can kind of step it step by step. And he eventually returns like the final path. And here it's actually kind of like every time, if we get to the end, we try to pop this thing. This will be like the last node. So we kind of have to handle like the fact that like we might want to like extract the latest path over and over and over again. So I think we need to say like do like an early return here. I'm okay with reconstructing the path every time. That's fine. So here I kind of want to do like, we can check if the final node ID self G scores. We need to know kind of where the last node ID, which node we came from initially, or on the last node in order to do this. So it's not really trivial. Instead, we'll do this. We'll say self final node is equal to current node ID. That seems reasonable to me. Okay. And then we can have a final node here. So we'll say final node is a star node, but an optional A star node. So he'll start at null. And then we can say on each step, if final node is, if this exists, we just kind of immediately do this. Oh, fn is not a valid identifier. We'll say n, I guess. There, so this means that every time if we step, if we get to the end and we keep stepping, then it'll be fine. Okay. Then this is like this. Yeah, that makes sense. And then it should be that externally then we can run the path planner to completion. So let me think for a second. So on render, I guess we're gonna kind of have like this, all of like the debug state that we're visualizing can be attached to the normal render loop. So we can kind of like do all of this stuff where we look at the internal state of the path planner and we say, hey, which nodes have you looked at? We can look at them and then render these points. I guess it's only this, scene G scores. This is the part that we want to do. So it's kind of like all of this gets stuck in this if statement. And this just comes into like the main render section. So it comes like this. If we are debug pathfinding, draw all the nodes. But now just pp is now if self path planner is a pp, we do this. Boom, like this. Okay. Okay. Thinking. So then we can also render like the current path here on the render. So we can kind of say like if self path planner, I guess this kind of indicates that this if condition should be swapped like this. Then we can be like if we have the final node, then we can call pp step, and we can get like result is this. Okay. And then that's kind of this stuff here. All of this stuff here. And we can assume that this succeeds if we have the final node already, which is great. Okay. And so now all we have to do is like add buttons to say run to completion and step once. And that actually solves a bunch of things. That also solves the fact that we can't debug like the slow iteration is like a shit show. Now we don't have to run the path planner as we move the mouse. We only run the path planner once we've picked the final location. So that's going to help a lot. So we can go here, and here we just add some buttons in our native Glyphwa app. So we have like start path planning, and instead of this end path planning button, I kind of want a like I kind of want this to say like run finish path planning, and here we'll say like step path planning. And I kind of want these all, they can be under each other, fuck it, I don't give a shit. It would be nice if we did like all in one line, but I really shouldn't care. Okay, so if these things are clicked, then we have to like handle them in some way. So if actions path planning, we're gonna replace finish stop path. We're gonna replace stop path with like finish path, and then we'll have like step path planning goes to step path, and then we have to implement those. So this is gonna be like step path and finish path. This is silly. Path start. This shouldn't be constructed on mouse move now. This should just be done on start path. So we just like fucking rip this new path planner here. Right? And then that means that like path start, I guess, just doesn't have to exist anymore. So path start here is just we update on each mouse move, the closest node. So that goes here. Step path just calls like self path planner step. If self path planner pp step, right? And I don't actually care about the result here because the render loop is going to figure out if it wants to draw anything. And then here we're just going to call pp run instead. Except here we actually do care about this because this returns like an allocated thing sometimes, so we actually have to be a little careful here. So we can say like if this gives us a p path alloc free path, which is a little weird, but you know, it's fine. It's fine. It's a weird API, but we'll live with it. Okay. And I think this has to be tried actually, which means that this has to be tried. He's mad about node ID here. What the fuck is going on here? Path planner init. Start end, right? So node ID here has to be end. So, oh, I've changed my mind. We want the end to be the closest node. Which means that this has to be path start. Ah, so we go, I was wrong again. We actually do want to construct this thing on mouse move. Because we reconstruct the path planner every time we move towards a new node. That makes sense. That makes sense. So this is on mouse move. We bring it back. So if self path start, we do this, which means that this is not self dot path start here. This is path start. No field name path start because we deleted it. That's true. Path start is a node ID equals null. And then on start path, this we go self path start is equals self closest node. Okay. Oops. But I think the rest is good. I think the rest is good. Expected type void found out of memory. Ah, so render now can fail. Okay. That's fair. Error unit is ignored here. Step is not marked pub, but it should be, so that's fine by me. Path planner is the wrong type here, pp.step. So here we need like this to come in by reference, by pointer. He's mad because we tried. Probably we need to then do this. error union is ignored at all of these renders. And all of these things don't return void. Okay, I'm gonna go back to the render thing. I'm just gonna make this not return an error. That's just easier. So here we will just kind of say like, if pp step res like this, and then all this goes in like this. This is gonna be like this. And this isn't even like, really, this should be like more like a catch. Like, here we should be like pp step, catch, return, or else return. Like, is kind of what we want here, I guess, which is kind of weird, but it's fine. And then here we'll do the same thing. We'll say like, or else return, or catch return. And really we should fix me log, but you know, I don't care right now. Error union is ignored. So this, now we don't have to like do that anymore. I guess we want to run smap. Let's see if this works. Let's see if it works. So what I'm hoping to see is, I'm hoping to turn on debug path planning, and I'm hoping to see, make site. I'm hoping to turn on debug path planning. I'm hoping that as I click step, I kind of see like the red dots branch out. That's what we're hoping to see here. Then I'm hoping that when I click finish path, that it will kind of like jump to the end location. That's what I'm hoping for. We'll see what happens. We will see. We have to build the site first, though, because we are no longer using the transit stuff, so we give them a sec to think. Build the site, and then we will run. Calling it a site is a little silly when we're using the native version, but you know, whatever. Whatever. All right. So here, I kind of hope that I can do start path planning, go here, finish path planning. Nothing's happening. That's not good. Debug path planning. Start path planning here. Nothing's happening. Step, nothing's happening. So just nothing's happening across the board, which is not what I was hoping for. So app zig, we are probably because this is happening all the time. So here we probably want to check if like this is moved. So we probably want to do like if self closest node is not equal to we want to do like if self path planner and closest end is equal to closest node. So we'll say construct needs new path planner is equal to this, needs new path planner is equal to true unconditionally, right? Because if this isn't there, then we need a new one. Then we can say if needs new path planner, we do all this. Did you remove setting path start? That's very possible. I don't think so though. Start path here, path start equal closest node. I think it's fine. But we'll see. I think it's more likely that the main loop is just like immediately overwriting the path planner every single frame, and we're just not seeing it. That's what I suspect is happening. But we will see. We will see. So start path planning, run over here, debug path planning, step. Nothing's happening still, finish, nothing happens. Okay, so let's try to figure out here. Let's like say like std log error warn starting new path plan like this. And we should see this logged one time, but if something is going horribly wrong, we will see it 0 times or a lot of times. We'll see which one is the one that's happening. It's one of the two, though. Maybe not. Maybe it's just not doing anything. Who fucking knows? I don't know what's going on. So start here. Start path planning. We're seeing it no times. Surprising. That's because this is backwards. It should be not equals. That should be not equals. And then also, oh yeah, that's fine. The rest seems okay. The rest seems okay. We'll see. Dude, that garbage truck is so loud. Holy shit! I feel like it's like making my like apartment shake. So here, even start and then moving is still supposed to construct a path planner. It's still not. So here we can just kind of start being like path start. Needs new is a needs new PP. And then here we can be like mouse moved. What's going on here? Yeah, that seems fine. Which one of these many things have we done wrong? Who knows? Who knows? Give him a sec, he's thinking. All right, start path planning. Nothing? Nothing. App zig. Start path. Okay. Are we just not calling this in our like native glyphwa? Like, hello? Stood debug print ret any. And then here, like, I mean, he's mad that error union is ignored. That's fair, but that means that like, how is this even fucking compiling? What the fuck? So this shouldn't have compiled at all. I don't really understand. Yeah, I really don't, but that's okay. If, oh, this is like else, like this. There we go. Okay. Expected optional type, because this needs like error that we discard here. Yeah, I'm really confused. Maybe I didn't save something? Because I don't really understand how this is working in the first place. Okay, so now we're getting like log spam, which is very cool. Let's kind of turn that off. That's fucking annoying. Yeah, that was weird. Yeah, because I feel like the build and should like not have like, yeah, it must be that I forgot to save something and didn't notice. Like that's the only reasonable explanation in my mind. Okay, so here let's start path planning. Debug, step finish. Okay, so this is working. The debug path is showing in white, which is annoying. But you know that's a something. It would also kind of be nice, actually, probably to after finish, not reset, right? Because then we could like actually like inspect it a little closer, which would be kind of nice. So even actually on step, it would be kind of nice. But I don't really know how to manage like the difference. I guess on when you hit start until the first step, you might want to like be resetting it. But I'm just gonna leave it as is for now because that's easier. Let's at least though fix the color that we draw the points in should be red. But other than that, we'll leave it as is. Because this is working good enough, I think. I guess I don't know if we checked if step was working, but I do want to, if that's working, then we're like in a good enough state to debug. And it doesn't have to be perfect. Nothing ever has to be perfect. Step. Oh yeah, that's kind of nice, hey? So here we just kind of see like step. We start to see like other nodes get visited eventually. That's going to be really painful to debug, I feel like. We might want to add like a number of steps that we run at once. But let's kind of start here and just kind of see what it looks like. Actually, yeah, let's yeah, we can always just change it in code if we want to. That's fine. Okay, let's git add-u, git status, git diff staged. So add the path planner, we move some stuff around. Yeah, let's just commit and say add a debug whip debug visualization of path planner steps. And then we can just finish this rebase, and it's gonna fuck up all sorts of places, but we can just kind of like manage those. So here, transit integration wanted it to look like this. We want it to look like this. This is in render. We just do both. Wonderful. We just do both. Good to see the end square brace mascot is still wrong. Sometimes I delete him and he just comes back. That guy's a little bit of a elusive one. Here we have path planner. Here we have bus trip times and path start. I guess we just take both. Seems. Oh, path start's probably in here twice now. He is, so get rid of one of them. Here we have in the R version, we did this stuff. So this is what we want now. But presumably we did some stuff on the other side of this that still needs to get done as well. So I think it was that the new path gets replaced with new path the init. There's just like API changes. I think everything that we did on the like bus side will become very clear very quickly what needs to get done. So I think we'll just delete everything and we'll just fix the compile errors that come along with that. Here, the path planner step, we added the current node thing, and on the other side we did Jesus, this is fucked. Okay, so we take these changes for sure, and then these changes are supposed to get merged with these changes. So let's kind of look at the difference here. Hub function step, that's good. And then we just want this self final node thing. Everything else comes from the latest and greatest. Even this needs to be planned path like this. Okay, then this stuff is fine. Final node is equal to this, so here we just need to add in the final node thing on the right side. And then we keep going. Seems reasonable. Here we need to do, I guess here the final node needs to be a little more than this. It needs to be a with F score, node with F score, like this. Because we need the time elapsed as part of him. So here will be like, we just kind of copy paste this stuff. You've been in a middle rebase this whole time. Yeah, I do that. And I can see why people might be like, why the fuck would you do it that way? But it is the way I do it. It is the way I do it. There is some risk there because if your rebase goes like horribly awry, then you might lose the work, but the ref log should bail you out of that. So I'm not really too worried about it. Okay. I expect the build to fail now because some of the API changes were not reflected in like the original left side of things, whatever, however you want to call it, the debug visualization commit. And we just kind of ignored those, so we can fix them now. App zig. So this is going to be in function render. And it's going to be around here somewhere. Trouble, please tell me. Maybe we need to refresh our NeoVim to try to get him into the right state. Still no? Really? What if I save? Still no? He should be yelling at me. He should be yelling all sorts of shit at me. Oh, there we go. We got there. Okay, so path planner init expected 12 arguments, found 8. So we just have to correct these. This is a self-way lookup. And then it was like self movement speed and self path planner start time. What the fuck did I just do? And then there's another one that we missed. So movement speed, path start time, way lookup, and then it was the bus trips, which was after the adjacency map. Boom. Nothing worse than coming back to a hobby project after 3 months and you're realizing you're 10 commit deep interactive rebase. Dude, that's the worst. I just give up and start over. Or just like close the project and don't even work on it. It's just like, fuck this shit. This is now self. It's like res dinit with the allocator, I think, is the new way this works. And I think now we're chilling. We're close. We're close. He doesn't. There's some free that's not working at step path at 389. Right, because this is now also path dinit. Self alloc. And there's probably one more of these. More? Where's the last one? Oh no, he's fine. It's just the language server isn't caught up yet. Okay. So now we should be able to like visualize we should be able to visualize like why it's not taking the bus. Fuck. Instead we're seg faulting. Let's do I mean, I know that we need to rebuild the site, and it's very, and I know we do no sane validation of, you know, we don't do any validation of the data right now. We should, but we don't. Just knows the ball machine is missing. What's going on? Yeah, I mean, it's just like there wasn't enough room on the right side for me to show everything that I think that is important for the stream. So the ball machine goes. It'll be back though. Once we finish this like path planner shit, because the like amount of context we need will go way down in that scenario. All right. Maybe better? No seg fault? No seg fault, please? Nice. Warning, mouse moved. What an awesome warning log. We love to see that. Okay, so let's kind of say that, you know, we'll start like very close to the bus stop. Wait, is it not bridged anywhere? Oh, it is here. It's just an invisible bridge. That makes sense. So if we like start like right here, and we'll start at you know, 15 times 60 times 60 is 54,000. Start around 3 o'clock. I don't really know when the bus should start, but you know. And then here, if we turn on debug path planning and start stepping, fuck. That's annoying. Annoying. How's the satellite image loading so fast now? On the native version, it doesn't have to do a bunch of web requests. It just can like read off disk, which is way faster. Segmentation fault, core dumped. So what is going on here with all these warnings? Can we like get rid of these? They're fucking awful. Oh, and then this got to the bus at. And then I think I want to take like more than one step at a time. But also it was seg faulting and we needed to debug that as well. So can we do like release save? And I don't know which part of this shit show is seg faulting, but we'll find it. We'll find it. Run. Please, sir. And also, I think some of the like satellite loading time is hidden by the window not opening because we don't like put it in another thread like we do on the web version. Not thread, but you know, we don't do it asynchronously, whatever you fuck you want to call that. So here I just like went over here and then I hit like finish and it crashed. Which is happening at render. Interesting. So here trying to render the path is crashing. Good point. Good point. We do have to only render it, you know, we do want to like not use invalid memory. Oops, oops, oops. All right, let's see if that's better. Okay. So we were doing like start here, go up, finish path. Okay. Okay. Then we move and it resets a bunch, and then we want to like. It's interesting that even like just initializing the path planner is taking that much time. Okay, can we like maybe like just start spam clicking the step button? And maybe we want to just change this to step by like 50 at a time or something. It's fucking annoying. But I guess we should probably, maybe we just make it a runtime value. Maybe we just make it a runtime value. So maybe we can be like step amount. Would be like CIG input int, be like step amount, and we will use self step amount 0 0 to see what else is in here. Flags also 0, and then here step planning will be like if we click the button, we step by some amount. Like this. This guy gets kind of indented back a little bit. This turns into a optional number of steps, which will be like a U32 or something. Starting at null, we need this like step amount to be a thing that we keep track of. So we'll kind of just like step amount is a U3201. Okay, he expects a cint. That's fair. That's fair. So here we'll make him a cint, and then step amount, step path planning gets a cint, which he already did. Wow, look at this go. Oh, because we fixed the wrong one. That will also do it. Type of bool ignored. So here we'll just kind of, I don't care if it changed. We don't care if it changed. Expected type bool found this, so we'll have like amount, and here we kind of slap in a int cast of amount. Right here we get like a amount. And here we'll say 4 0 amount. We do this. We fucking discard the index. We don't give a shit. And then here will be like return. Boom. Boom, boom, boom. Okay, I think that's fine. I guess our input should limit the range of things that we can get. So here, I think that we can't put bounds on this. And instead we just kind of say like if self step amount is equal to the maximum of 0 and self step amount. That way we won't end up out of bounds and we don't have to worry about that int cast crashing us. And that's kind of the fun thing with immediate mode GUIs, is like you just kind of like go behind the widget's back and you're like, no, fuck you, I won't do what you say. All right. Let's see what happens. Let's see what happens. So we start, by this bus stop right here. And we go over here. And we said it was like 54,000 was when we want to go, because that's, around the time that a bus might leave. We could actually look for specific times where the number 7 will leave, but that's okay for now. Debug path planning on, we start stepping. We don't see anything. Maybe because we didn't start path planning. Did we? I feel like we did. I don't remember though. Start path planning. Oh, we must not have, because it's now slow as shit. Slow as shit is good. And let's just kind of like start stepping. We start seeing stuff. And can we step like 50 at a time? And I just kind of want to see it like. So here it did end up taking this bus, which is kind of interesting. Well, he never took the 7. So he kind of went like here and then over here. I want to see these bus stops taken down here. Oh, and I guess we finished, so we'll kind of... I want to like... It could be actually that that was just a faster path. So maybe let's try to go like downtown. Like, let's just go over here. I wonder if it's just fucking working. There's like a very real chance that it is faster to go to UBC, take the 480 to the 99 to... Is this the Canada line? This is Burrard Camping. No, so this is the 99 to like the 10 or something. And it's just very possible that's faster than waiting for the 7, which is actually anybody who's lived in Vancouver and tried to take the 7, that's actually like a really funny answer. That's just faster. Anybody who's tried to take the 7 ever is like, yeah, it probably is. That's crazy. It's hard for me to know if that's correct. But, you know, I'm not like fully against that being the right answer, to be honest. That's really funny. So what I should do now is actually, let's try, can we restart path planning kind of like somewhere where that wouldn't happen? Like here? And then try to go downtown from there? So there, now it's like harder to get to the express buses. Oh, yeah. There we go. See, we see it happen. We see it happen. He took the 7. And then he took the 7, and the 7 goes down 4th as well. And so maybe the 7 just doesn't do what I thought it did. But that's a real... Like, this looks really fucking good. I'm not gonna lie. That looks fucking awesome. The path is getting drawn under the bus route, so it's kind of hard to see. Let's just kind of fix that. That's actually, like, really... Like, I'm actually, like, so fucking stoked. That's really fucking cool. Function render. So here, let's just make it so that the bus routes get drawn before the path. So that the red line goes on top of the blue lines. But yeah, like watching the way it was crawling there, it looks really fucking good. Like, it's doing exactly what I wanted it to do. I don't know if what I want it to do is optimal, but that felt good, right? Because you can kind of see it like start spreading out around where it starts, right? So we're going to start kind of like, is this McDonald? Yeah, this is. So here, like the 22 will take us down to like Burrard somewhere. I can't remember if the 22 goes this way or this way. I think it goes down here. So we can kind of like expect that if we step 50 steps at a time, we start here, we end up kind of by Burrard Street somewhere. No, it must be this one. I think this is Burrard, this is Granville. No, this is Burrard. I'm an idiot. This is Burrard here. So here, if we start step in, we should expect it to walk down the 22, come down Burrard. Instead, we're not debugging path planning, so we see nothing. I don't see anything at all, actually, which is a bad sign. Finish path planning took fucking forever. Also not great. Oh, because we were starting at midnight, and the 22 probably doesn't run at midnight, and then we probably crashed because there's some sort of bug somewhere. Maybe there was no bus at that time before. And I think that what ended up happening was it just took a really weird route that I didn't expect because of the fact that it was by the express buses. Like, if I start right here, it's going to take this 480 to UBC because that's like really fucking fast and take the 99. So it was just the path that we were seeing wasn't really what I expected. But that's okay. So here, let's try to coerce it into taking the 22 to downtown. Let's just see if it does it. Debug path planning on. Holy fuck, it's slow. Holy fuck, it's slow. Oh, I forgot we have to keep this centered. That's annoying, but that's fine. So step by 50. And let's just see. Red dots? No red dots anywhere anymore? Why is there no red dots being drawn at all? How bad did we fuck this up? I don't really understand. We took the bus rendering stuff. and we moved it up here. Here, do we set the color every time we render anything? So it feels like that should work. I don't really understand why nothing is happening now when before stuff used to happen. I also don't understand why Zig build. Like, shouldn't this do something? Oh, maybe it's hashing. It's hashed the input file, and so even though I had just saved it, it's not stupid like make, where in make if you touch and recompile, the thing will recompile because it's using mtime. Here we're using like the content of the file, which is kind of interesting. Because I feel like we didn't change anything major here to the point where we shouldn't pathplan at all, right? If I hit like start pathplanning here, and I run over here, I try on debug. Oh fuck, where the fuck am I? We'll start pathplanning here, and we won't even try to go to a bus stop, and we'll step pathplanning. Like I should see. Oh, when I hit finish, I see a red line. But debug pathplanning is not doing anything for some reason. Debug pathplanning in native GLFW sets it on debug pathfinding. Debug pathfinding gets set on debug pathplanning. Try taking the box before starting pathfinding. Oh. No, I don't think that should make a difference because it's checked on every render call. So I don't think so. Yeah, there's something else going on here. Oh, they're just being drawn really small. The points are just being drawn like incredibly fucking small because the bus point size, this modifies point size, and so here we just need to make sure that we set the point size the way we want them, which was like 10.0 or something before. Oops. Classic mistake. Classic mistake. I hate state, man. I don't know if I've ever said that before. But I feel like the vast majority of programming is like trying to manage the fact that you have to deal with state. And man, like that's why people love like functional programming so much, is because like you just like remove the problem. But yeah, it's fucking annoying. Okay, so I also forgot that we want it so that we leave at 54,000 seconds in the day. We're trying to schedule around 3 p.m. And now let's zoom out a little bit and step by 50, turn on debug pathplanning, and there we go. So he's walking. And here he's actually, you can see him like straight line it towards the different bus routes that are close by him. Here you see him do it again. What I don't fully understand is I would think that we should end up on the 22 at some point here, and that's not happening. But you can see him like walking towards, I really like the way he's walking towards whatever bus stops are available. Oh, here it looks like he's finally getting on some buses. Maybe the 22 doesn't run anymore. I wonder if the 22 is just not like a reasonable bus to expect to go there. Because I haven't really been over there for a while. But you can definitely see the fact that he did something. So, oh, here he did end up on the 22 down to the 99, or maybe this is like the 9 or something, down to the Canada line to another bus to walking. So we've got a problem where he's like doing all sorts of transfers. But it is really interesting seeing him like walk the paths of like this is where he, like, look, he ended up like fucking like over here. That's really funny. Maybe that's fucking stupid. There might be a bug here about we probably want to limit the heuristic to looking for buses that are like within a certain time. We probably want to prioritize time in some way that we're not right now. But this is definitely fucking sick. This is definitely really fucking sick. Probably need to add resistance to transfers due to missing transfer. Yeah, for sure. At some point I'm gonna add in I want to run a daemon on my machine. Daemon? I don't know what you're fucking supposed to call them. That monitors the bus, like the real-time bus data, and compares that to the schedule, and that will give us like a like, I'm hoping, some sort of distribution of like reliability of the bus in some way. We can convert that into like a reliability number, and we can use that to tune like the transfer logic and stuff. But yeah, also like we should, even in the case where transfers worked perfectly, we should be able to, we should bias towards taking the same bus, right? There's no point in me first switching from two buses that run the same route. Like, why would I get off and get on over and over again when I could just take the same bus? So there's definitely something there. But yeah, this is fucking sick. This is fucking sick. I'm actually like really fucking stoked with what I'm seeing right now. That's a really, really good sign. Obviously, there's all sorts of problems here. I don't know if it's taking an optimal route. I don't know if it's like what, it's slow as shit. We need some sort of like debug visualizations for it to tell us like which buses it took. That's not like shown anywhere, and that should be shown somewhere. We have all sorts of code that's like broken and stuff, where like, how do I say this? Like, I think that like the WebGL app is not working at all right now. Right, there's all sorts of problems here. I think that we are close to a point where I would like to commit this behind like a debug flag. Probably, I think we could probably commit this in its current state if we could get to the point where like the slowdown cost, like whatever like the transit cost is, we could maybe like cut that out somehow. Right, if we can add like a checkbox here that says like take the bus or don't take the bus, then we'll be in like a pretty good state to like kind of build on this. But I think that we've been working on this for like a week at this point, and we've like changed a lot of code. There's been a lot of churn, and I would like to get what we have in, and maybe like there's a piece of me that wants to take a break from this because like my head's been like in bus planning route mode for long enough that I'm like kind of sick of it a little bit. So I think what's probably going to happen is I will probably spend tomorrow trying to clean this up to the best of my ability. And then we should swing back on Wednesday for another mainstream of, I think that what the next thing I want to work on, we'll maybe take a day or two on adding, I want to add like search for location just for some variety. But yeah, maybe show bus next time for each stop on the UI. Yeah, I agree. We'll probably come back to that at some point because obviously like I can't this project has to go to the point where buses work. I just want to take a break from it. So that's the plan. Tomorrow we're back for happy hour only for cleanup of this stuff. Day after, we will be doing integration of like business licenses where we can say like where are A&Ws, right? We can like do for something like that, and then we'll see how long that takes and we'll see what comes next. Cool. All right, thank you for watching, guys. I'm pretty stoked on this. If you liked what you saw, we stream most days at around 2:30 to 4 o'clock, or sorry, 12:30 to 4 o'clock Pacific time. If you check the Twitch description, you should see a YouTube link where we have all of our projects organized in playlists. We're working on this map right now, but there's other stuff, right? People like the video editor, the QR code decoder I thought was really fun. The terminal emulator was fun. Operating system was fun. Image to text neural network, all of those were fun. So if you want to check those out, they're there. GitHub will have links to whatever projects we're working on. Map is this one. There's a Patreon link and Discord link. Discord's for if you want to chat, if you want notifications about like when we're going live or like extra little tidbits I'll post in there sometimes. Patreon will have archives of a happy hour VODs, or if you guys just want to like throw money at me, like, subscribe, Twitch Prime, you guys know the dealio. And I think that's it. YouTube, I will see you later, and Twitch, let's find someone to raid.